All right, CRVA 8.06. This is going to be part 2, and here we're going to be evaluating geometric series. So if you look at the function in this series, if you were to graph it, which you don't have to do, if you were to graph it, that would be an exponential function. So there's not a consistent rate of change through addition, but rather it is through multiplication, as you've seen this unit. So in this case, we need to use a different formula. So the formula we used before was for arithmetic series. Now this is for geometric series. So there is your formula. Notice a sub 1 is the initial output value, and then you have to put n into the equation to calculate that. Sometimes I'll show you a shortcut, and then n is the number of terms in the sequence, and r is the rate of increase. Guess I didn't write that down. Rate of increase, and this is going to be through multiplication. All right. So here you'll notice that there is no multiplier out in front. So it's actually going to be a 1. And so if you were to plug in 1 for m, you'd have negative 4 times 1 minus 1, which is negative 4 to the 0. Sorry, I said times. That's negative 4 to the power of 1 minus 1. Now this is negative 4 to the power of 0, which is 1. It's going to be whatever that number out in front is, that multiplier is out in front. In this case, I put that 1 there just to show you that trick. The rate is the base. The rate in this case is negative 4. And the number of terms in this series, we're going from 1 to 8, so that is 8. So the sum is going to be my initial value, which is 1, and then we need parentheses, and then that's always a 1 right here, minus, in parentheses, our rate, which is negative 4, raised to the power of the number of terms, which is 8, and then we close our parentheses off. And folks, this is what I typically punch into my calculator first, is this output, and then we divide that by 1 minus the rate, which is negative 4. Notice that's a double negative there, folks, so that really is going to equal 5. And you could have taken your output from right here, punch this green part in the calculator, see what you get out, and then divide that by your, in parentheses, 1 minus negative 4. Or maybe you're going to do that mentally. That's just 5. So you can take your output divided by 5. But if you're going to divide by more than just one term, you need to have that in parentheses. And also, these parentheses right here are super important. And it's important that you put the power, in this case of 8, in between the two right parentheses. So when you calculate this, you should be getting number 21, should be getting negative 13,104. 107, just kidding. There we are. I'll leave that there for a second. And then I'm going to move on to number 23. So number 23, we need the number of terms, which is 8, because we're going from 1 up to 8. Our a sub 1 is going to be the multiplier out in front, which is 1. And our rate is negative 6. It's whatever the base is. So to get our output, to get the sum of these 8 terms, we take 1, which is our initial value, times 1 minus, because that's what the formula always is, our rate, which is -6. Notice I'm putting that -6 in parentheses, and then raising it to the number of terms, which is 8. And then I close off my parentheses, and I'll punch this into the calculator now. Should get negative 1679615, negative 1,679,615. But we're not done. We need to divide that by 1 minus the rate. 1 minus -6, which is 7. So I'm going to take that answer, divide it by 7, and we get negative 239,945. There we are, folks. It's really important on these that you write out your work. If you do make a mistake, maybe hopefully you can go back and see what you had written down, see if there was a boo-boo. I'm going to erase number 21, so we can do number 22. What's nice about these is while like the geometric series it's harder to see the pattern per se, but you don't have to calculate as much initially until you're ready to go to the big formula. You just need these 3 things: the number of terms in this sequence, the rate, and the initial value. So the number of terms in this sequence, we're going from 1 to 8, which is 8. The rate is the base. And the initial term, so I'm going to just show this. So 1 is my initial term, so I put 1 in for n. We'd have 4 times -4 to the 0. -4 to the 0 is 1, so it's really 4 times 1. So again, the initial value is always going to be this multiplier out in front. The rate is always going to be the base. The number of terms is the top right here, minus the bottom, plus 1. All right, so here we go. Initial term is 4 times 1 minus, in parentheses, the rate, close parentheses, raised to the power, which is the number of terms, close your parentheses. Punch that into your calculator. I get negative 262,140. And that answer gets divided by 1 minus the rate, which is 5. And so then we get negative 52,428. Boom. All right, I'm going to delete or erase number 23 and go to 24. Okay. A sub 1 is going to be my multiplier out in front. Because if I plug in n minus 1, I should have taken back what I said. It's not always that multiplier out in front. Because they change it to n plus 1 sometimes. Eesh. So maybe we should always calculate. But when you plug in 1 there for n, you get 1 minus 1 is 0, which is going to essentially wipe out and make that just a plain old 1, all that stuff in there. Negative 2 times 1 is negative 2. So I guess we do have a calculation that we need to do. But the rate is 3. Maybe color code it. The rate is 3, and the number of terms is 10. So let's go for it. So it's your initial value times 1 minus the rate raised to the number of terms. Mind your parentheses. When we do this, we get, make sure you got a calculator that you trust, folks, whether it's an app I get 118,096. And that gets divided by 1 minus the rate, which is 3. So 1 minus 3 is negative 2. This gets divided by negative 2. Which gives us an answer of negative 59,048. All right, that's 21 through 24. When you go up through 29, they're all very, very similar to that, folks. When we get to 31, it's still a geometric series. However, what changes is our initial input is now 3. We can use the same equation. Our rate here is going to be negative 4. Our number of values, careful, remember it's now 3 through 8. So take 8 minus 3, that's 5, but then add 1. We have 6 terms here, 3, 4, 5, 6, 7, 8. Now it's not going to be a sub 1, it's going to be the first term in this series. So it's going to be a sub 3. So we're going to plug 3 in for m. So we're going to have negative 4 and make, ooh, Mr. B typed this poorly, very poorly. You have to use parentheses around that base. Because negative 4 squared means negative 4 times negative 4, which is positive 16. And if you don't use those red parentheses, folks, you get the wrong number, and that stings. So the value of our first term is 16. That goes up there. Then 1 minus the rate, which is negative 4. Put that in parentheses, raised to the power of the number of terms, which is 6. I'm going to punch this into the calculator now. Negative 65,520. But that gets divided by 1 minus the rate. 1 minus negative 4, which is equivalent to 5. So we get negative 13,104. Let's move on to number 33. 33, we need the rate, the number of terms, and the first term in this sequence. This sequence is starting at the 4th term. So the rate is my base, which is negative 2. The number of terms, 8 minus 4 is 4, add 1 is 5. There are 5 terms in this series, and we need to find the output for that first term in the series, which is an m value of 4. So I'm going to do 3 times negative 2 to the 4 minus 1. You can just punch that all into your calculator. Depending on the calculator you're using, you might have to use parentheses around that 4 minus 1. But if you know that the 4 minus 1 is all up in the exponential level, then you don't need to. My calculator doesn't have that, so I need to tell it that. 3 times negative 2 to the 4 minus 1. You get negative 24. So negative 24 is going in for my initial output, my initial value. So negative 24 times 1 minus the rate in parentheses. So 1 minus parentheses negative 2. Close your parentheses. Raise it to the number of terms. Close your parentheses again. Calculate this output. I got 792. But then that needs to get divided by 1 minus the rate. So 1 minus negative 2, which is actually 3. So I get, for number 33, oh, you know what? I think I forgot I did. So my answer is wrong right now because notice this 24 is negative, folks. And in my calculator, I forgot to punch in a negative. I did a positive 24. So that would make it a negative 792, which would make my output negative 264. There we are. And we'll try 32 and 33, 32 and 34. Rate, number of terms, first term in the sequence, which is when m is 3. The rate is negative 5. The number of terms in the sequence, 8 minus 3 is 5, plus 1 is 6. The third term in the sequence, so let's figure out what that is. I'm getting 1250. So to get the sum of this series, we take the initial value, which is 1250, times 1 minus the rate, which is negative 5. Notice my parentheses there. That's pretty looking. And now calculate. Wowzers. 19. Oops, that's a negative. Yes, that's a negative. Negative 19530000. The thing is, if you get good at knowing how to use your calculator, folks, you don't actually have to write that part down. You can just take that answer in your calculator, depending on the calculator you're using, and realize that you have to divide it by 1 minus the rate. So 1 minus negative 5, which is 6. So I'm just taking that big, long answer that's sitting in my calculator and dividing it by 6. And we get negative, I said negative, but I didn't write it down. Oh, just 3 zeros. So negative 3,255,000. There we are. All right, last one here, folks, number 34. Number 34. Rate, number of terms, first output in the series, which is going to be when m equals 2. So the rate is 3. Number of terms, 11. 12 minus 10, 12 minus 2 is 10, plus 1 is 11. I think you get 6 there, but you know what? I'm just going to double check with the calculator really quick. It doesn't hurt. Yeah, that was silly. 6. Never hurts, whatever. Been a little cobwebby lately. Alrighty, so that's my initial value. So the sum of the series is going to be 6 times 1 minus the rate in parentheses raised to the number of terms, which is 11. Let's get rid of that squiggle so it doesn't look so messy. Divided by 1 minus the rate. But let's figure out what this top output is first. Negative 1,062,876 divided by negative 2, because 1 minus 3 is negative 2, You get 531,438. There we are, folks. We can do these geometric series sums, segment notation. It's all good stuff.